What if everything the experts said was impossible wasn't? A Bugatti Chiron Per Sport sits in a small garage, and not just any Per Sport. One of only 6 he ever made, now completely destroyed. The front end is caved in, the aluminum frame twisted, the gearbox compromised in ways that make seasoned mechanics wince. According to everything we know about cars like this, it isn't meant to be rebuilt in a place like this. It's meant to be written off, forgotten, or shipped back across the world to the people who built it. Yet someone is about to defy every one of those expectations. What unfolds next isn't just about a car. It's a direct challenge to the impossible itself, and the stakes have never been higher. It all started with a crash that sent shockwaves through the hypercar world. Alex, a fellow creator and close friend of Matt Armstrong, was behind the wheel when his Per Sport met its violent end. The damage was immediate and catastrophic. The entire front structure was crushed inward, aluminum buckled where it was never supposed to bend, and deep inside the car, the gearbox had taken a hit that most engineers would call terminal. When the photos surfaced online, the consensus was unanimous. Write it off. No question. But Matt Armstrong doesn't think the way most people do. Where everyone else saw a corpse, he saw an opportunity screaming for defiance. Bugatti moved fast. Within days, the manufacturer reached out with an official repair plan, a 6-figure job to be carried out at the factory under their direct supervision. But there was one strict, non-negotiable condition. The car had to be repaired in one of only 2 authorized facilities on the planet. No exceptions. No alternatives. CEO Mate Rimac himself later posted a video addressing the situation directly. Calm, precise, and unmistakably serious, Rimac looked into the camera and laid it out plainly. There are only 2 places in the world that can do this. It requires specialized equipment and specialized training. He emphasized that attempting to rebuild a Chiron Per Sport outside these controlled environments could result in catastrophic failure, and that driving such a car could carry life-threatening consequences. The video racked up hundreds of thousands of views within days, and suddenly the stakes weren't just mechanical. They were public. The whole world was watching, and the narrative had been set. Bugatti was the authority. Matt Armstrong was the reckless underdog. David versus Goliath, except David's weapon was a welding torch and a garage full of stubborn determination. Matt didn't flinch. He negotiated a buyback price of $1.9 million, took possession of the wreck, and rolled it into his workshop, knowing full well what he was walking into. This wasn't a stunt. This was a high-stakes mission where every single decision carried the weight of financial ruin, reputational destruction, or total mechanical failure. Backing down simply wasn't in his vocabulary. The garage transformed overnight into something between a surgical theater and a battlefield. Matt and his team began the painstaking process of dissecting the Per Sport piece by piece, documenting every bend, every crack, every fracture mount with obsessive detail. The cameras rolled constantly. The public watched through their screens, some shaking their heads in disbelief, others quietly cheering the sheer audacity of the attempt. Every frame inspection, every weld test, every moment where something unexpected appeared was magnified under the scrutiny of Bugatti enthusiasts and hypercar communities worldwide. Social media erupted with debate. Could Matt really split a Chiron in half, repair catastrophic structural damage, and safely bring it back to life in a workshop that had no business touching a car like this? Or would he prove every one of Bugatti's warnings right and create an expensive, public disaster? The first real test came early, and it was the one Bugatti had specifically said was impossible outside their walls: splitting the Chiron in half. The car's architecture demands separation of the front and rear sections to access the engine and gearbox, a procedure that requires specialized lifts, proprietary tooling, and trained factory technicians. At least, that's what the manufacturer insisted. Matt's garage had none of that. What it had were basic lifts, hand tools, and a crew that refused to accept someone else's definition of what they could and couldn't do. The team began with a careful disconnection of wiring harnesses, fluid lines, and structural mounts. Every cable and every pipe had to be accounted for. Every bolt had to be inspected before it was touched. The surprises came fast. Hidden fasteners appeared in places nobody anticipated. Corrosion on internal brackets threatened to stall progress entirely. The carbon fiber monocoque revealed structural quirks that could easily throw off the alignment if handled carelessly. Each discovery was met not with panic, but with focused, methodical problem solving. Matt called out measurements, cross-referenced torque specifications, and kept the energy in the room steady even as the pressure mounted. What made this phase extraordinary wasn't just the complexity or the danger, it was the speed. Bugatti had stated that this procedure required weeks in a controlled factory setting with purpose-built equipment. Matt's team completed it in days. When the two halves finally lifted apart, the moment was jaw-dropping. Clean, precise, and almost absurdly efficient. Matt stood between the separated sections, grinning at the camera, and pointed at the two halves sitting side by side in his workshop. It was both a literal and symbolic victory. The car that couldn't be split outside a factory was now in two pieces in a garage in England, and every skeptic watching had to reckon with what that meant. But the split revealed something far more sobering than anyone had anticipated. With the car opened up, the full devastation of the crash became impossible to ignore. The force of the impact had shoved the engine forward, crushing the coolant pipe and wrenching connections that were engineered to remain fixed for the lifetime of the car. Worse still, the cast aluminum engine and gearbox mount, the structural backbone holding the entire powertrain in place, was fractured on both sides. Clean breaks ran across the metal like fault lines, evidence of just how violent the collision had been. Matt stared at the damage for a long moment, exhaled slowly, and then quietly told his team they needed to assess everything before making a single move. The inspection that followed was exhaustive. Every bolt, every bracket, every fluid line was examined with the kind of attention usually reserved for aerospace work. And buried inside all that destruction, they found something that changed the trajectory of the entire project. The deeper engine block was intact. No cracked pistons, no shattered cylinder heads. The internal gearbox components appeared untouched. The core of the car, the thing that makes a Chiron, was still alive. Relief passed through the garage like a wave, but was tempered almost immediately by a hard reality. The mounts were critical. Without functioning engine and gearbox mounts, nothing else could be reassembled safely. A single miscalculation at this stage could erase weeks of progress or render the car permanently undrivable. Matt's team measured the fractures, checked alignment against every reference point they had, and began planning how to reinforce or replace each broken section. There were no factory replacement parts available to them, no tech support hotline to call. Every broken mount meant a new problem that had to be solved from scratch, figuring out how to weld, reinforce, or fabricate something stronger than the original casting without introducing new damage to the surrounding structure. The margin for error was essentially zero. This was where Bob entered the story, and his role cannot be overstated. Matt Armstrong's most trusted fabricator, Bob brought decades of experience and hands that didn't shake under pressure. Every hypercar rebuild reaches a moment where the outcome hinges on one person's skill, and this was that moment. The team started with a weldability test, carefully applying controlled heat to a sample section of the fractured aluminum to confirm the metal could be fused without cracking or compromising the grain structure. When the test came back clean, a wave of cautious optimism passed through the garage. This was the green light. Bob began welding the fractures with precision that bordered on surgical. Sparks scattered across the workshop floor. Metal glowed under the torch. Each bead of weld was scrutinized from every angle, Matt and the team hovering close, watching for the smallest flaw, the faintest sign of weakness. But welding alone wasn't enough. Matt insisted on reinforcement that would take the mount beyond its original factory strength. Using additional aluminum bracing and a carefully planned welding pattern, Bob built up the structure around each fracture point, layering strength on top of strength. The goal wasn't just to fix what was broken. It was to make it better than it had ever been. Every angle and every connection point was tested with measurements and stress analysis. Matt documented the entire process, showing before and after comparisons and detailed close-ups of the weld beads, turning the repair into a transparent record that anyone could evaluate. Even in the most carefully planned operations, things go wrong. While tightening one of the mount bolts, a sharp snap echoed through the garage. The fastener had failed under incorrect torque. The room went still for a beat. Then, without drama, the team replaced the bolt, recalibrated their torque wrench, and carefully finished the job. These moments, the small failures that could spiral into catastrophe, but didn't, defined the character of the rebuild. Matt's team had learned to absorb setbacks without losing momentum. Each obstacle reinforced their discipline instead of shaking their confidence. With the mounts repaired and reinforced, reassembly began. This was a phase where weeks of meticulous disassembly, welding, and fabrication either came together or fell apart. Matt and his team reconnected everything. Wiring harnesses threaded back through the chassis, fluid lines for coolant, oil, and brake systems sealed and pressurized, and a custom Valvetronic exhaust upgrade integrated into the system. Every single connection mattered. A missed wire could cause a short that would fry the electronics. A misaligned fluid line could star the engine of oil or coolant under load. The team moved with a deliberate pace of people who understood that rushing now would destroy everything they'd built. Then came the moment the entire project had been building toward. Matt climbed into the driver's seat. The garage was quiet except for the hum of overhead lights and the faint clicking of cooling fans. He placed his hands on the wheel, took a breath that carried the weight of every sleepless night and every fractured mount and every snap bolt, and pressed the ignition button. The W16 roared to life. The sound filled the garage like thunder, resonant and deep and unmistakably alive. The engine idled with a steadiness that seemed almost impossible given what it had been through. Vibrations were smooth. Fluids were flowing. Every electronic system responded exactly as it should. Without hesitating, Matt shifted into gear. The transmission engaged cleanly, smoothly, as if the car had never been touched. The Chiron Purr Sport wasn't just repaired. It was functional. It was real. It was running in a garage where the entire automotive establishment had said it never could. The video documenting that first engine start exploded across the internet. Millions of views arrived almost overnight. Comments flooded in from every corner of the car world, a mixture of disbelief, admiration, and something that felt very close to vindication for every independent mechanic who had ever been told they weren't qualified to touch something this complex. Matt's expression in that moment said everything. It wasn't just satisfaction at hearing the engine run. It was a culmination of philosophy he'd carried through every setback. That persistent skill and the willingness to be told no and keep going anyway could overturn decades of manufactured exclusivity. But the project was far from finished. Success in the engine start marked a milestone, not a finish line. The cooling system remained a serious concern. Early test runs had been conducted without coolant fully circulated, and even brief operation under those conditions risked heat damage that could quietly destroy the engine from the inside. Matt's team monitored temperatures obsessively, watching for spikes or leaks that might threaten the powertrain. Any oversight here, even a momentary lapse in attention, could unravel weeks of painstaking work in seconds. The front-end structural damage posed its own lingering threat. The crash had bent aluminum supports and twisted suspension mounting points in ways that wouldn't necessarily show themselves at low speed. Under high-speed operation, those compromised areas could affect handling, alignment, and ultimately safety in ways that were difficult to predict without extensive testing. The team reinforced critical points where factory components had been damaged, but even with reinforcements, subtle stress concentrations remained hidden beneath the surface, waiting to reveal themselves under the wrong conditions at the wrong moment. Modern hypercars like the Chiron are as much electronic as mechanical. Engine management, traction control, gearbox operation, and dozens of interconnected systems all rely on sensors and software working in perfect harmony. Any misconnection, any vibration-induced fault, any alignment deviation could trigger cascading failures that no amount of mechanical skill could fix on the fly. Matt's team spent hours testing every sensor, verifying ECU signals, and hunting for anomalies in data streams. The electronic architecture had to synchronize perfectly with the rebuilt mechanical components, a challenge that required patience and standards that left no room for approximation. One detail that captured the imagination of viewers was the starter motor. The rebuild used a unit sourced from a Volkswagen Polo 1.9 TDI, a humble diesel engine component adapted to serve in one of the most exclusive hypercars ever built. It was a perfect emblem of the entire project philosophy. Resourcefulness over prestige. Function over pedigree. The starter worked exactly as intended. But its presence under the hood of a purse sport was a quiet reminder that this car had been brought back to life through unconventional means, and every adapted component carried both ingenuity and risk in equal measure. The perception of the project had shifted dramatically. What had begun as what many dismiss as a publicity stunt, a YouTuber in over his head, had evolved into something the automotive world couldn't ignore. With the engine running and systems functional, the conversation moved beyond spectacle toward a harder question. Could this car be made truly roadworthy? Could it be driven not just around a parking lot, but at the speeds it was designed for, safely and reliably, without the blessing of the factory that built it? Matt Armstrong's rebuild didn't just generate views. It detonated a conversation that had been simmering for years. Workshops across Europe, Asia, and the United States began studying his techniques, from precise aluminum welding methods to the creative aftermarket solutions and fabricated components that replaced unavailable factory parts. Independent builders who had spent years being sidelined by manufacturer-only repair restrictions now saw a documented, proven path forward. The methods Matt and his team had pioneered were being adapted, refined, and applied to other exotic and hypercar platforms, turning a single garage project into a blueprint for an entirely new approach to high-end automotive repair. The broader implications reached well beyond workshop floors. Matt's project became a focal point in the growing right-to-repair movement for high-end vehicles. Petitions in both the EU and UK cited his rebuild as direct precedent, demanding that manufacturers stop blacklisting VINs and withholding parts from independent workshops. Where a wrecked hypercar had once meant automatic factory intervention or permanent scrappage, the conversation had fundamentally shifted. Independent repair wasn't just theoretically possible. It had been demonstrated, documented, and broadcast to millions. What began as one man's refusal to accept the manufacturer's verdict evolved into something far larger than any single car. Matt's defiance proved that technical skill, relentless planning, and creative problem-solving could dismantle barriers that the exotic car industry had maintained for decades. Workshops around the world now felt empowered to push boundaries, innovate without permission, and challenge a monopoly that manufacturers had long held over repair and maintenance access. This story is about more than Bugatti. It's about a fundamental shift in who gets to decide what's possible. The narrative has moved from spectacle to proof, from one man's garage to a global community of engineers and builders who refuse to accept that only a factory can fix what a factory built. Matt Armstrong's rebuild is now referenced in forums, technical communities, and industry discussions as a tangible demonstration of what happens when independent minds refuse restrictions. His work has sparked new collaborations, cross-border knowledge sharing, and a culture where capability, not corporate permission, determines what gets done. Matt Armstrong rewrote the rules of hypercar repair and turned a wrecked Chiron into a worldwide inspiration. The garage revolution is here, and it has proven that impossible is never permanent. If you want more groundbreaking rebuilds and behind-the-scenes engineering, hit like, subscribe, and turn on notifications. You will not want to miss what comes next.